do it? Okay. Now teach me how to do it. Send me a WhatsApp how to go about that. So, how was your morning? One batch was with me in a PLC lab. Not you. They were all 2020 batch, Division 2. So, we are 15 in the class at the moment. So, we are 18 cadets here. No, there are 7 here. 18th is me. Why people are joining late in the. Now, do you all go to the Moodle and receive your notes, etc.?
Can you be a bit loud?
Okay, I think I'm enough loud, but again, can you all use the Moodle to receive the notes which I give? You know how to do that? This subject is added to the Moodle. Do you use Moodle for doing assignments,
Yes,
etc.?
sir.
That is very good. Now, I was not on the Moodle, but I've been put now, so I'll be placing everything, some study material, at least about the trusses and a general introduction of the mechanics on the Moodle today. Now, dear friends, just tell all your colleagues that class must begin in time. You are in hostel too, there are no connection issues, and a lot of people come, they keep loitering and then come at any time they want to, is something bad. If we can begin the class in time, we can end about 5 minutes earlier, 10 minutes earlier, provided we begin sharp at 2. Remember that. Okay, dear friends, we are 30 cadets now. 5 are still doing something which is more important to them. But we begin hereby and just be with me. So, you all smarties, we had started working with this trust in the last class, and today we are going to continue with it. Now, this is a bridge truss. This is normally used in the bridge. This is used on a bridge. There are other varieties also. Now, HJ, JK, KL, LM, MG, FG, EF, DE, CD, BC, AB, and AH. These are all external members, and these are all internal members. This truss has a 12 joints. J is equal to 12. 1, 2, you count, it is 12. And the element 21. Members are 21. As a result, they obey the equation M equals 2 into J minus 3. Now there are trusses which will be having a M less than 2J minus 3 or greater than 2J minus 3. If M is equal to 2J minus 3, then it is stable and statically determinate. If it is greater than 2J minus 3, then it is stable and statically indeterminate. And if it is less, then it is unstable. And once it says unstable, it cannot be put into the practice. So anybody thinking whether it is a statically determinate or not is a not at all a question. There is no need to spare a thought about it. Okay, but remember this. Yes, you can ask me. You can make this discussion interesting by showing you curiosity, etc. Anything you want to ask? I normally don't believe in muting the whole class. Yes, because all of you, I respect your personalities, and I know you will make a good use of it by asking the question. Kindly don't start your cameras, otherwise the screen can come over here and it disturbs the view over here. Fine. So, yesterday, our last class, we found out that these reactions are 40 kilonewton and a 40 kilonewton. Again, let me remind you that to analyze the truss, all the loads has to be on the joint only. I cannot give a load over here and try to analyze the truss. It will not be possible to analyze the truss, or rather it is not a truss at all. In the truss, all the elements, all the loads come on a joint only by definition. Okay, then we look at the equilibrium of a point A. On the point A, element AH and the element AB are giving a force, and there is a support reaction also. From knowledge of this support reaction, we have to find out the force in the element AH and the element AB. For that, we will take a closer look at a element joint A. This is a joint A. Now, one thing is sure that support reaction is upward and a 40 kilonewton. We know this force, magnitude also and a direction also. Now, this element AH is either giving a force in this direction or in this direction. I do not know. AH is either pushing this point or pulling this point away. Same way, this element AB over here is either pulling this or pushing this is not known. But for direction of a AH and a AB are very much known. And again, what is known is that this particular joint is in equilibrium. So sum of a all zero as a result, as a result, sum of the x component of a 40 AH and a AB is a 0. And the sum of the y component of a 40 FAH and the FAB also is 0. Now, let us first consider the sum of a y component of all the forces. This force is acting in a positive y direction. It does not have any x component, so 40 is positively in a y direction. Again, this force AB is purely in the x direction. It does not have a y direction, so it does not contribute to force in a y direction. But FAH is having a component in a y direction, and that will be like this or like this. Now, if sum of the y component is supposed to be 0, then my dear friends, y component of FAH should be equal to 40, and it must be in a downward direction. Then and then only it can neutralize this 40 kilonewton in an upward direction. Has each one of you understood this? Is there anybody in the class who would like to have a debate on this? Daksh, Bharadwaj, Daksh,
Yes, sir.
have you understood this clearly?
Yes, sir.
Chaitanya Duggal,
Yes, sir.
have you understood this much?
Yes, sir.
Biradar, Bhuvan Biradar,
Yes, sir. I understood, sir.
Devansh, Gaur and Tandon, have both of you understood this?
Understood, sir.
Yes, I understood that.
Okay, then I have one cadet, Harsh Sharma and Harsh Yadav. Sharma, Yadav,
Yes, sir.
have you understood this?
Yes, sir.
You are a Yadav or a Sharma?
Harsh Sharma, sir.
Okay. यादव तू कहाँ है भाई?
Yes, sir.
ये समझ में आया?
Yes, sir. आ गया.
कुछ पूछना नहीं है?
No, sir.
जगताप, संकेत जगताप, कुछ पूछना चाहते हो? देखो जगताप भैया सो गए हैं, कोई बात नहीं, सोने दो उसको. प्रवीण, जतिन प्रवीण 8084. प्रथमेश जादव, आज क्या बात है, सभी जादव सो रहे हैं?
Sir, he is sleeping.
हाँ, जादव, प्रथमेश, ओके, कोई बात
He
नहीं,
is sleeping.
सोते हो तो डिस्टर्ब नहीं करना
He
चाहिए.
is sleeping.
Okay, fine, no problem. It is good if you understood this. And sometimes, it is so easy and I'm repeating something, people sleep, I don't mind. Now, if y component of AH, is downward, then tell me, AH can be like this only, yes or no?
Yes, sir.
Okay, right? So AH is in this direction. Fine. Now things become interesting. FAH is having a sine theta component here. So this is FAH sine theta. That should be equal to 40, which I am writing over here. Right? So FAH is a 40 by sine theta. Okay? And FAH is in this particular way. Its direction is this. Correct? Acha. Now, FAH, which is 40 by sine theta, its y component is matching with 40, and its x component will be like this. If x component is like this, which is 40 by sine theta into cos theta, which is 40 by tan theta, that should be equal to FAB, and FAB must be in this direction. then and then sum of y component will become 0. बच्चे लोग समझ में आया इतना?
Sir.
हाँ, so FAB, first of all FAH cos theta, this is FAH, इसका cos theta यहाँ पर बन गया, that has to be equal to FAB, so that is equal to FAB, so FAB is equal to 40 by sin theta into cos theta, which is 40 by tan theta. Now AH and AB, are they in a tension or a compression? It is very easy to decide. Look here, I am showing a joint A. Here it is connected by element AH, and here it is a connection of a element AB. Actually all these A are at the same point. Now one thing we have seen, that AH is pushing the joint. So joint is pushing the AH, isn't it? If joint is pushing the AH, if AH is pushed at A, it must be pushed at H only. Otherwise AH cannot be in equilibrium. As a result, if something is pushed by both the ends, this long rod, then this must be in a compression. Right? Now AB is pulling point A. Look, it is in this direction. So element AB is pulling the joint. So joint is pulling AB at A. So at B also it must be being pulled by the joint B. Now element AB is pulled by both the ends. So it is in tension at both the ends. Does anybody would like to have a further debate on this? Does anyone want to understand it further? जतिन बेटे तो जाग गया कि अभी भी सोया है? चलो कोई आवाज मत करो, उसको नींद डिस्टर्ब नहीं करते हैं हम. अब we have concluded that AB is in tension and AH is in compression, right? And that is the reason AH in a compression I am showing, and this is in a tension I am showing. Now one thing is there, AB is in tension, so A is pulling AB, so AB is pulling A, so this force should be like this. AH is in compression, so this force should over here like this. These forces are on the joint and not on the members. Okay. Now having worked on the joint A, we can come to the any joint nearby. Either we can go to the H or we can go to the B. Okay. Let us go to the joint H first. This is the joint A, so joint H. Where is the joint H? Joint H is over here. This is a joint H. Now, this is a element AH. Here there is a element AH. Sorry, it is not like this. A, and here it is H. We know the direction of a AH and the magnitude also. It is 40 by sin theta. AH is in compression. If it is in compression, it will try to push the joint away. So it is acting like this. So for a AH, we know the direction also and a magnitude also. Then there is a load over here. This load at this place is acting downward, and magnitude is a 8 kilonewton. Now there is a Hj, I am showing it in compression, and Hb I am showing in a tension. Why I am doing so? Reason is very simple. Sum of all the forces is 0. So sum of the y component of all these forces also is 0. And the sum of all the x component of these forces also is 0. Now let us first consider x component. This does not have a x component. This does not have a x component. This is a totally a x component, and a 40 by sine theta has a x component. This is theta, so this is 40 by sine theta. This angle is theta into cos theta. So this is 40 by tan theta, acting from a left to the right. So Hj must be from right to the left. Am I right? Correct?
Yes, sir.
Right? So I am showing it over here. Fhj equals Fah into cos theta. Fah is a 40 by sine theta into cos theta. That is equal to 40 by tan theta. Okay. So now we all know that Hj is in this direction. It is 40 by tan theta. Correct? Now let us have a sum of all y component. This is totally a y component. This is y component. This does not have a y component, so we remove it. Now this is by 40 by sine theta. 40 by sine theta is bigger than a 40, and its component over here is a 40 by sine theta into sine theta. So this force, vertical component of this force is 40 only. So here 8 downward, 40 upward. So we have a, because of these two, I have a net force 32 upward. So HB must be 32 downward. चलो बच्चों, ये बात समझ में आने जैसी है? आ गई आपको कि ज्यादा कुछ डिस्कस करें? प्रथमेश, अरे ये जेफी,
Yes, sir. Yes,
Jeffy.
sir.
Jeffy, have you understood this? Jeffy, okay, you are sleeping.
Excuse me, sir.
Ah, yes.
Sir,
Jafi.
sir, I am.
Jeffy, you are not sleeping. Okay, good.
Yes, sir.
And we have a Dubey or a Dhruvo, I don't know. Devansh Gaur. And
Yes,
there is
sir.
and there is a Devansh, one more Devansh also. Tandon.
Yes, sir. Devansh Tandon.
Have you understood this much? Any doubt?
No, sir. Understood all.
Okay, good. Now, having done this, we can say here also this element is in tension and this is in compression. This is 40 by 10 theta. This is downward 32 only. Okay. Now we come to the joint B. We are at a joint B. At joint B, there are 1, 2, 3, 4, 5 forces are coming. This is a very interesting junction. But we know that there is a force 8 kilonewton downward and a 32 kilonewton upward. Both are in a pakka y direction. So ultimately it is a 24 Newton upward. We can simplify it, but we are not simplifying it. FBJ, FAB is 40 by 10 theta. Why? While we're dealing with the joint A, we have found it out, isn't it? We have found that out and we will not forget it that easily. Done?
Yes, sir.
Now, let us consider the balance in a x direction. If we consider balance in a x direction, we don't know FBJ is which way. But one thing is sure, sorry, we consider y direction. FAB does not have a y component. FBC does not have a y component. This is 32 and 8. So we have a net 24. So FBJ must be having a 24 downward, isn't it? If that is the case, then FBJ sine theta should be equal to 24. So FBJ is a 24 by sine theta and it is a this direction. Done. Now this is a 24 by sine theta. This is 40 by sine theta. Over here it is. Now this has a component 24 by sine theta into cos theta, so 24 by 10 theta. This is 40 by sine theta, then we added to it as a 24 by, sorry, 40 by 10 theta this is. 40 by 10 theta plus 24 by 10 theta, so this is 64 by 10 theta. And again it is in tension. So we have finished our work over here and we further know that BJ also is in compression only. Okay. This is in a compression. Again, this is in a tension. This was 40 by 10 theta. Here tension is more. It is 64 by 10 theta. Right? This also is in a compression over here. This is vertical member is in tension. Good. Now we can come to the joint K and the joint C. Which joint we shall go?
Sir, C.
Okay, good. Thank you, Cadet. When somebody replies, I feel very happy. But here I have gone to the joint J. A joint J, we have found out HJ. So HJ we know. If somebody has to, mute himself. He is listening to some cricket commentary or football commentary, I don't know. But kindly mute yourself so that we are not disturbed. Cadet, whosoever is a
Jafi,
Yes.
your mic is on.
Jaffe, take care. Yeah, so here we are again. We have found out FHJ. We know the direction also. This 8 direction is known. Then FBJ also is known. Right? FJK we do not know. But one thing is sure that HJ is in this direction. Our BJ is in this direction. So BJ has a component in this direction. So HJ and BJ both push the joint rightward. Now 8 cannot push it rightward, JC cannot push it rightward. It's a job of a JK only. So FJK is a FHJ plus FBJ cos theta. So again, that turns out to be a 64 by tan theta. FBJ that is. Then, if we worry about sum of the forces in y direction is 0, then this is 8. FBJ is a y component over here. FBJ sin theta, right, is 24. Why? Because BJ is a 24 by sin theta. 24 upward, 8 downward. So we have a 16 downward. So we have a 16 upward. To take care of a 16 upward, this has got to be a 16 downward. Here it is. JK in the compression and the JC is in the tension. Now, we come to the point B. Now, point B is unique. Point D, sorry, not B. We have to come at a point C first. And point C is analyzed over here. Trick is very same. I am putting this on the Moodle. So you study it yourself and thereafter there is a point joint K. Joint K is on the top. And it is analyzed in a more or less same way. There is nothing challenging in it, because when we come to the point K, then we have a JK which is like this, and known it is FCK also is known. This 8 is known, right?
Yes, sir.
And from the symmetry, we can say that FEK is equal to FCK, because our entire truss is having a uniformly loaded, symmetrically loaded, correct? So now finding out FLK and FDK by these two equations is simple, dear friend. There is one very interesting way of finding DK. DK also we know already. No need to come to the joint K. Why? Let me tell you something. Let us go back to the original figure. If you consider a joint at a D, observe it. Now, here there can be a pull or a push, we do not know. Here there is can be a pull or a push. Only force known is over here is a 8 kilonewton downward. This is 8 kilonewton downward, and sum of the y component of all the forces is 0. CD has a no force in a y direction. DE also has a no force in a y direction. So DK must be pulling it upward, right? So this is 8 already. If this is 8 downward, then this is 8 upward. Is this clear?
Little bit, sir.
Tension in a KD, moment you look at the beam, even without finding this support reactions, you can be sure that here this element KD is pushing the joint upward, pulling the joint upward. KD is pulling the joint, so joint is pulling KD, so this particular part is in tension, and it is a magnitude is a 8 kilonewton. You cannot say anything about the CD or a DE. Both may be in a tension or both may be in a compression, we do not know. For that you have to work it out. But in general, in this kind of a truss, what happens in this kind of a truss and this kind of a loading, of course, truss will try to deflect downward. Look, dear friends, suppose I take a one solid rod, support it at a two end, and I give a force like this. Then what will happen? It will try to bend like this.
Yes, sir.
So this is a concave part. Concave part will come in a tension, and this is a convex part is in tension, and a concave part will be in a compression.
Compression.
Why? Because if bends like this, then central line remains as it is. And this length is less than this length is more than this length is equal to this particular length over here. As a result, this has got expanded and this has got contracted. So this is in compression and this is in tension. So now here also this truss will deform slightly like this. So all this element on the bottom will be in tension and these all elements are in compression. Now all these are in a compression and these all are in
Tension.
tension. But if you make a truss in a slightly different way, I will show you how. If this truss was made like this, we will solve one such problem later on. Other things are this only. Then this long part will come in a tension. These parts will come in a tension. And these vertical parts will come in a compression. We have to see for ourselves by solving a problem, and we will do that, dear friends. So this was a method of joints. The same truss we will solve on Monday by method of section. Okay, so kindly at least go on the YouTube and find some videos on the trusses. Have a look at that. You can have some very interesting questions. Now, one thing I would like to tell you is there are sometimes trusses which are, a cantilever. That is, one end is free. Here is a wall. Here is a fixed joint. Sorry. We have a wall. and the truss is hanging like this on the one end only, another end is in the air, and then maybe here a force is given. Remember this. Now, suppose there was no force here 8 kilonewton. Then what will be the load in the decay? Any idea?
No, sir. No idea.
No idea. Good. We know that one thing is sure, that sum of all the forces acting at this point is 0. So their y component are 0. Force in the CD and the force in the DE has a no y component. This is a known y component. So force in the decay has to be upward 8 only, isn't it?
Yes, sir.
If this had been 20, this also would have been 20. If this would have been 15, this would have been 15. And it means that if you remove this and if this is 0, then a force in this also is a 0. Do you get it?
Yes, sir.
It will not take any load whatsoever. So this is a 0 force member if there is a no load here. In any truss, if at any point there are two elements in the line and a third element is over here, or maybe vertical, or like this, then this element has to be a 0 force member. The reason being, suppose at any joint, this is a joint P, this is Q, this is R, and this is say S. Then S will be having a two components. One component over here and another component like this. But this component will not be neutralized by any member because there is no member over here or here or here. As a result, this component has to be 0 and this also got to be 0. As a result, if anywhere three members are meeting, and if there is a third member also is similar meeting, and the two of them are in a straight line, if two of them are in a straight line, then third one will be a 0 force member only. Understood? Is this clear?
Yes, sir. Clear, sir.
Okay. Again, if at a joint there are 3 members, but here there is a force acting, then this need not be a zero force member, because component this will be neutralized by this, and a pull over here and a pull over here will balance y direction force. Okay, so that is another story. When 3 members meet and the 2 are in a straight line, then third member will be a zero force, provided there is no other force acting over here and there are 3 members only. Then this is 0. Okay. Now again, if at truss only 2 members are meeting, and 2 members are not in a straight line, they may be like this also. And here there is no force acting. If no force is acting over here, then this element and this element, both of them must be having a zero force. Do you agree with me? Because two vectors having a non-zero value and meeting each other at an angle other than 180 degree, their sum can never be zero. Here also, this may be in a tension and this may be in a compression, or both may be in a tension. Whatever you take, net sum will not be zero. Yes, if they are in a straight line, then both may be pulling the node or both may be pushing the node, and they may be non-zero. But in any truss, two members meeting, and if there is no force acting at that point, then it is both of them are zero force element. And if in any truss, if there are 3 elements meeting and 2 of them are in a straight line, then third one must be a zero force member, provided there is no other force acting over here. Correct? So we had a nice interaction today. I thank all of you for your patience. And now there are 34 cadets are present. Everybody has come finally.
Yes, sir.
Okay, Animesh, so let us say everybody is present today. Thank you very much.
Okay.
Be in time in the class. If you start sharp at 2, Animesh, then I'll always conclude at a 2:45. That is my promise, because you need a 5 minutes to breathe something and close your mind and open mind again. Fine. Have a nice day, all of you.
Thank you, sir.
Thank you, sir.
And Jai Hind to everybody.
Jai Hind, sir.
And pray God that the war in Ukraine and Russia doesn't become so intense that India also is required to send a peacekeeping army over there. If that happens, then there can be some tough time for our soldiers also.